before class, I just want to point out something about the homework, just because I got a question about it and I realize it's not super clear in the homework, and that's for homework number 2, homework 2, that is scheduled for this Thursday. The question was about what the pull request is about, and I'm going to go ahead and go to, just going to demonstrate what that looks like. So if we have some repositories, or if we have a repository, I guess when I first clarify, a pull request is a GitHub specific feature. It's not a feature of Git, it's a feature of GitHub. So it's it is not something that is universal to every version of Git. Rather, it is just the company GitHub invented the idea of pull requests. So if we go to I have an example repo I see here called Crispy Barnacle. And I see I have 2 branches here. This is the one I was working with class. Actually, wait, no, I only have 1 branch. Let's make a new branch. Actually, I'm going to go over 2 things now. Do I still have Crispy Barnacle somewhere, or do I have to reclone it? I may have to reclone this guy. So to clone, again, I just can copy this URL, or I can copy the URL here and paste it in there, and then it'll clone into a directory it'll create. So now I'm seeing this repo, and now I'm going to create a new branch, kind of like what we're practicing last week. So git branch, and we're just do like new test branch is what I'm going to call it. I'm going to do git checkout new test branch to switch to it. If I type in git branch now, I see I have master and new test branch. So I have 2 different branches now, master and new test branch. Master was the default. And then I can make some sort of change. As an example, I'll just open up that Python file and make some changes here. I don't like this file. I'm going to change it to make a change. Git status. I see that I've modified this Python file as expected. Do git add-a, git commit-m to create a new commit. Remember, a commit is like a frozen copy of all your work at this moment in time. So made some changes to Python. So what I've done so far is I cloned the repo from GitHub, which is what you always want to start with, unless you already have it cloned. If you already have it cloned, you can just work from there. And that created a new directory, which I then CD'd into. I created a new branch. I used git checkout to switch to that branch. And now I made a change on Python. For Linux users, you can use gedit to open it up. And that's just the text editor I was using. For Mac users, you might want to replace that depending on how you have VS Code. You might be able to use code, C-O-D-E, to open it up if you're using VS Code, or SUBL if you're using Sublime. That's only if you have it set up the right way. Sometimes it doesn't work. Then you can open up the Python file that way. So then I made some changes to Python. I do git status again. Sure enough, it says nothing, working tree clean. So now here's the first thing that threw off some people, is that when I try to do a git push, it just says fatal, the current branch, new test branch has no upstream branch. So that fatal sounds pretty scary, but it does not mean you're going to die. Good news. It has nothing to do with that. In fact, this is expected. What it's saying is that GitHub doesn't know about this branch yet. And when something is a fatal error, I guess I should be clear what that means. That just means the program won't run. It won't do what you told it to do. If a fatal error is one where it just can't continue. In this case, it's just going to stop because GitHub doesn't have this yet. And it wants to make sure you know what you're doing. Like, wait, did you mean to do this? GitHub doesn't have this branch yet. Was that an accident that you're trying to push this up? It's really to try to catch an accident. Maybe in some cases you might want to make a branch locally, but you never send it to GitHub because you don't want anyone to know about it. It's just a little local branch you made just to try something out. So that's what this is about. It's just saying that, hey, you're trying to push to GitHub and GitHub doesn't know about this. It gives you a command to run. And if you run this command, you're going to be fine. So that's the solution to this, is it actually tells you what to do. So we run this command, and then type in info, and then it says, we refresh, and see, look, it just says your recently pushed branches. It created a new branch right there. And then, so now the next thing that some folks had questions about is pull requests, because that was mentioned in the homework. To make a pull request, you first go to the branch, and I mentioned pull requests are features of GitHub. They're not features of Git in general, but features of GitHub, the company that was bought by Microsoft. And it's a very misnamed feature. The term pull request should not have been called that. I think a better name for it might be like merge discussion. I think that's a better name for it. Basically, it's a way for people to discuss whether or not we should merge branches. That's pull request. So it's a feature allows engineers or developers to discuss if they should merge a branch or not. So it's really about the social aspect of GitHub. It's not about it's not a feature of Git itself, but it's related to features of Git. But it's more about it's a feature that people use on GitHub to better facilitate code review. Code review is where one developer pushes their code and other developers look at that code and check it for mistakes. So that's what pull requests are for. It's a feature for code review. So then we do compare and do pull requests. We click on that. I can write a comment like, this is a great change I made. Please accept it. It is great. So we do create pull request. And now the idea is I have a link up here that in a company I would actually maybe even just like go on Slack or on chat and just send that to another engineer to take a look at it. Like, hey, can you review my work? That's the idea of a pull request, is it gives you this link, and then what they see is they can see all the commits you made, and they can look at all the files changed. See, it shows all the different changes I made. I deleted all of this and just replaced it with that. So, that's what they get out of this. And if they like it, they can actually click. So I could do this to myself too. If they like it or I like it, I can actually just click merge pull request. Certain companies, though, limit that button. That button won't appear for people who aren't approved. So that's how companies regulate who gets to review code. In this case, it just by default appears for everybody, and anyone can merge pull requests. So I'm just going to click merge, confirm merge, and then what happens is what it's actually going to do now is it's actually going to do a merge behind GitHub is going to do a merge on their copy of your code, merging this branch into master. So merging the branch you made into master, which means then master will now reflect the change that I made. So it actually merged it back into master. That's only when you click merge pull request. So again, pull request, confusing term. It should not, I don't think it should be called that. It should be called something like code review or code discussion or merge discussion. Should I merge? All great names for it. Yes?
There's a Git feature called release pull.
Yeah, those are all unrelated. So it's totally unrelated to Git pull, Git release pull. Those are that's why it's a really bad name, because there's already things called pull and release. And request, and all of those are words that have already been used and have nothing to do with pull requests. So definitely not the best term for it, I think, but it's the one we have. So any other questions? But the key is the idea of a pull, and this is for the homework. What you want to submit is actually your pull. You can merge up your pull requests. To see the ones you've already merged, you can go into pull requests, then click closed, then click over here, and you can just send this URL here, and that's what for homework, you can submit that URL, and that's what we can review to make sure you did a pull request and use branches correctly. And the goal here is, in real life, you're not going to be accepting your own pull requests. That's a little bit weird. Maybe you will be, but typically you don't. So this is more just to get the practice of if you're on day one of the job and they're like, can you make a pull request? Send it my way. And you're like, what's this? Well, now you've got some practice. What is a pull request? What does that mean? And that's what it is. And I guess another cool thing about pull requests is you can actually, check this out, you can actually add comments to code, like this part is bad. And this is, and then, you know, and you can actually see it, so it actually has discuss. I didn't really show that, but it actually has a full discussion feature GitHub has, where GitHub users can discuss any line of code in the pull request. And that's kind of how you get feedback about the different code. And maybe like replace this and resubmit, something like that. That's a pretty common thing, like, you know, clean this up and resubmit, looks good otherwise. That's a typical response. Any questions about this? So this was about the homework that's due on Thursday before we get into new content for today. Yeah?
Just repeat, you just want that, when we submit it, you just want that.
The URL.
That's it, okay.
Yeah, just the URL is good. You don't have to add any fake comments or anything. So just the URL, and then just so we have something, just so you show that you've actually made the branch, done the pull request, etc. Because part of the homework that's due on Thursday is getting more used to GitHub. That's part of what's due essentially. Okay, cool. So let's get to new stuff today. Welcome to week 3 of Kickstart coding. It's amazing we've gotten so quickly, and now we are diving into Python. So that'll be you, that'll be Python knowledge, and look something like this probably. Because this next week is going to be all solid Python topics. So remember, hang in there. It's hard. This is tough stuff. It's expected that you're going to feel a little frustrated. So whether or not you feel like this climbing this mountain, or maybe feel a little bit more like this, drowning in an ocean of so much information, it's hard. You will get it. It'll eventually, things will click. Sometimes it takes longer. No one's the same. Don't compare yourself with other people too, because no one's the same. It may take longer for you. It may take a little bit longer to click. It may also require just more repetition. Everybody's learning style is different, which means you have to ask questions, study ahead, code and practice every day. You're learning a new way of thinking. You're changing your brain right now. You're changing your brain to restructure it around a new way of thinking. Anyone find coding just kind of counterintuitive and like using a computer with like a terminal and stuff, right? It's like, it's really literal, right? It's like, this is not how you're used to communicating. You're used to communicating with people, not computers. And because your brain's not used to that, it requires a lot of change. And we're trying to make that change happen really quickly, which is why this is so hard. But you can do it. You will do it. And it requires, again, studying, practicing every day. Who here codes every day? Really? Everyone's hand should be up here. So, cool. A lot of you are, which is great, but everyone should be trying to do that. Code and practice every day, and that's the way you're going to keep up with it. So, let's talk about today's topics. We're going to do a quick review of some Python concepts. We're going to go right into some new data types. Containers, these are lists and dicts. That's just short for dictionary. We're going to also cover something called branching, pseudocode, input, and while loops. It's a lot of things. So we're going to go over them one activity at a time. We're going to start with some Python concepts. So let's get going with that. Variables, this is one of the most important concepts in any programming language. A variable is like a labeled bucket for data. Let's all do this, all right? So the thing on the right goes into the thing on the left. That's what the equal sign does. And it's, what do we call this? Operator? Assignment operator, yes, exactly. Assignment operator is what we call this. And the assignment operator makes the thing on the right go in the thing on the left. And another important thing is computers they have a very short memory in the sense that once it does this, it kind of forgot that it happened, right? It doesn't remember where it came from, which means if we put it from one variable to another, what happens if we change the Pokemon variable? Does Poke2 change also? I see you're shaking your head. Yeah, so if we change the Pokemon variable, Poke2 will not change. That's only if we do it after the assignment. because it forgets that it's done an assignment. It just is a one-time, put one thing in the other bucket operation. That's what assignment does, just a one-off thing. It does not remember that the two are associated at all. It's executes the line and forgets it's ever done it. It just remembers what's in the buckets. That's all a programming language knows. What is in its variable buckets. It doesn't remember the previous lines it's executed, only remembers what is in its different variables. That's all that changes when coding. So when we think of data in programming, we generally, a great deal of coding is just shifting data from one label to another, from one location to another. That's a lot of code consists of this. And the equal sign is what does it. And then operators are symbols like plus or minus, and also the equal sign. They combine data or variables, and values are what the data that's inside the variable. So variables have names and values. The name is the label of the thing. The value is what's inside of it. And so the same variable could hold different values throughout its life. It could be, you could put something in it and then put something else in it, and those are different values that are getting swapped out in the same variable. And what happens if name already had something in it before we got to this assignment operator? What happens to the old value? Erased. Goes away forever. What happens to our variables when the program stops running? Something remember this? Gone? Yeah, they're gone. Variables only last as long as our program is running. When the program stops, all the variables go away. How do we keep data around? Does anyone remember this? We did this on Saturday. How do we keep things from going away? There's only one way, yeah. Write it to a file. That's absolutely correct. There's a seat here. Yes. So the only way to keep the data around is to write it to a file, and then read it maybe to a file later on to access it. Files don't get deleted at the end of your program. It's only variables that get wiped out. So here's some examples of different types of variables. We have strings. Can someone get in their own words define a string for me? And I know I have words up there, but maybe in your own words, maybe more succinctly, just define a string for me. I want to go for it. It's text with quotation marks. Yeah, that's a great definition. That's definitely what it is. When there's quotes around it, that's a string. In Python, they often shorten the word string just to str. That's like the nickname in Python world among Python programmers. What's a Python programmer called again? Pythonista. Yes, awesome. So all of you Pythonistas can now call string str if you want. And it's short for a string of characters, and it holds text. Now that's whether it's one word, one character. It could be one letter, could be one word, could be a sentence, or it could be many megabytes long. It could be an entire book. That's all a string. It doesn't matter. Integer, int. That's a number without a decimal place. Float is a number with decimal places. And then here we have bool. So bool, notice there's no quotes around the true or false. We can actually write it like that, and that's because there's another type in Python called a bool, which is short for Boolean, and that's just the word true and the word false can also be stored in a variable. So in this case, turtles are liked, spiders are not. And it's good for storing if you just want to store true or false about something, not like a number or a message. Any questions about this? This is kind of the important stuff, some of the important stuff we covered on Saturday we're going to build on today. So numbers, strings, true, false, Python. Okay, let's get going with that then. So activity 1, Python warm-up. And we want to always start with a print, adding a print statement to a file. So notice challenge 1 is always is to mention to write Python code to print out welcome to week 3, save it and run it. And the reason we want to get in this habit is that has anyone maybe in homework started editing a file and then didn't understand why it's not working and then realized they're editing the wrong file? Yeah, everyone. Cool. So that happens very often, which means a good habit to get into is always add a print statement. That way you know you're editing the right file. So activity one Python warm-up. So to give you an idea of how to do that, we type in print, welcome to week 3, save it, Python 3, one Python warm-up, and this is what we should see for challenge 1. So let's see, we have a good Python result. I believe it. No, we don't do that. Yeah. Cool, we got a result. Now do control D to exit. Cool. Now download this file, and I want to. So you can start. That's actually the first. The first challenge is that to add a welcome to week 3. So we actually do that. Open this file up and run it using the code. Then that's
Yeah.
go over this. It's in live source.
Oh.
So control flow right there. most of the screen, we'll never go to a 5.
Got it.
Or you can't actually use comments here. So.
Oh, you can do?
Yep. So get out of this. First thing you want to do is connect to one of our heads. You're in the wrong spot. That's only just for testing stuff. We're in the wrong place. So first we have to do our application. So remember the CGC? I would do, like, how comfortable are you with that?
Not super.
Not super. Okay, so let's go to the monitor. And then let's, so this way you can actually drag the directory over. So wherever you unzipped it, unzipped it, that's it over here. And then you can drag activities over to the target. So, yep. And then that'll actually fill in the path. So you still have to type in C.
Oh,
So it's still all the way to the meeting. Does that make sense? Yeah. Hit enter. Okay, now do it on us. I'll show where we are. So, okay. That's the one. So now we do concentration.
got it. And that should.
Space one, tab. You just hit tab.
Oh.
Tab's all we need. You never want to type stuff out. Just constantly hit tab. Cool.
Oh, so
Now,
six.
save this and see, step one is at that print state. Oh, you're, you moved it after you opened it.
Yes.
So you have to reopen it. And then look at what's already solved the first challenge. Look at that. What's it saying? Oh, it's working. Cool. Oh, okay, that also works. We can do that.
What about like spaces?
We can do that. We can do that as long as we have those spaces. Yeah. So I'm going to be going over the first two challenges now. So challenge one is we add this print statement. Challenge two is we have to make some variables. We need to add name of your favorite NBA team, name of a team you dislike, how many points did each score. So home team, we can put in Warriors, rival team, I don't know, Cavs. And then home score equals 200, rival score equals 3. So this is how we create the variables using this. And remember, the thing on the right wasn't the thing on the left. This is how we can create 4 variables as an example. Then what we have to do is we need to I'm going to do challenge 3 now. Challenge 3 is fixing all of this code. So the first issue is, it's not printer, it's print. So we can delete that. Second issue is, what's the second issue with this one? What's wrong here? Rival team, yeah. Coding is case sensitive. Big R is different than little r. We have to make sure that that is consistent. line 43 has an issue too, and it's we're missing commas. What's the issue with line 44? What's missing there? Parentheses, yeah. And make sure you don't have a space in the beginning here, because spaces at the beginning of code mean something to Python, and if you cannot just add a space to the beginning of code. It will break. It'll say unexpected indent. So you want to make sure there's no space between the beginning of your code there. Let's work a little bit more, then I'm going to go over challenge 4. And we'll continue with some new content.
Yeah.
Cool. Making sense so far?
Yeah.
Oh, so here's the issue. We need to use plus signs, not commas. Commas only work for print.
So, my experience was as such. They're quite sticky. It creates a file which writes this kind of when I try to write that variable, it tells me that it is not a string. And when I try to convert it to a string, it gives me a
What's up? Yeah, what's up?
So, on an advanced bonus challenge, it says open to sports story that creates speed, and I'm not sure where is that from. Is that I think that's one of your. That's the one we just. I typed it.
Okay.
Fine.
So I'm going to do challenge 4 now. Using the string concatenation operator, that's called, also known as plus, rewrite the print statements. Is this better? Okay. Rewrite the print statements to write code that will combine the story as above, and instead of outputting it directly to the screen, put it in a variable called story. So we're going to take the code from here, and we're going to rewrite it. Instead of using print, we're going to put it inside a variable. And so we can have it's a variable called story. So we can do story equals. And now we can't use commas here. Commas were only for print. We have to use plus signs, the string concatenation operator. That's what that means, that fancy collection of words there. And there's one other tip. Typically, we only can put everything on one line, and that's going to get really long, right, if we put all of this on one line. So here's a tip of how you can, if you have a lot of things you normally put on one line, but you want to separate them out, if there's parentheses around them, Python's okay with it being on more than one line. So anytime you have parentheses, you can actually separate stuff up into as many lines as you want. And there also can be indentation if there's parentheses around it too. It'll ignore that indentation. So that those parentheses kind of make Python a little bit more tolerant of what you're going to put inside of them, which allows you to format this in a more pleasing and clean way, more readable way. So we want to replace all the commas with pluses. But that alone won't be enough. What else do you have to do? Like you come up with an error when that happens. What's the error that you get once you replace everything with pluses? Integers cannot concatenate with strings. So Python does not allow you to combine an integer with a string with a plus sign. It allows you to combine an integer with a plus sign. So what do you think 4 plus 4 is in integer world? 4 plus 4 is 8. So that makes sense to Python. So as an example, I'll open up a text editor here. Or I don't know, I'll do this. So 4 plus 4 in Python, it knows how to do that. And remember, this is the interactive Python that's good for testing stuff, but not really good for running your code in general. So I'm just going to use it to test stuff. 4 plus 4 it can handle because that's 8. It knows what plus does there. And it can also do plus with strings, like hello plus world. It knows how to do this. That becomes hello world. However, hello plus 4, if I can type, there we go. It doesn't know what this is because it doesn't know which version of the plus sign it should be using. Should it be squishing them together, or should it be trying to add numbers together? The solution is to convert the numbers into strings. And this is something we did not cover, so if it's like, whoa, where'd that come from? You're absolutely correct. It's one of those things that we just slipped in that we did not explicitly cover how to do. But ultimately, the way you can do it is by putting the word str and parentheses around the thing you want to convert. That'll transform this number into a string so you can combine it with other strings. And that's basically telling Python, yeah, I know you can't just add a string and a number together. Well, first turn this guy into a string, then you'll know what to do. What's up?
Will doing that work in a function outside of like concatenating?
Yep, it'll work anywhere you want. Anywhere you want an integer to instead be a string that's spelling out that integer, you do str like that. If you need to convert an integer to a string, you do that. If you need to convert a string to an integer, you do int. But again, this was the last challenge for it was a tricky one because again we threw in some stuff we did not talk about yet. Any other questions? And then to write it to a file, we do this. Cool. Let's go ahead and go on to new topics then. So we've talked about a few different data types. We're going to talk about more data now. Notably, we want to talk about a new type of data called container data type. So there's a category of data types. A container data type can contain other data. So container data type is a type that is, sometimes you could consider them as being plural. There's more than one thing that goes into a container. And the two most popular types are lists and dictionaries. Lists are when you have a sequence of things and you want to store all of those things, a sequence of, say, and when I say thing, I can mean string, I could mean number, any of those would work. I could even mean other container data types, but just anything else. So let's say I want to store, all the names of students in this row. I could use a list to store that, so it'd be a data type I could store many plural things in. Dictionaries, which are short for, are also called DICT, so dict. Dictionaries are kind of like a group of variables together, and it contrasts with lists in that order doesn't matter with the dictionary. It has a different way of looking up data instead of order, so it forgets about the order with dictionary. Dictionaries do not have order. We're going to take a look at some concrete examples of these in a moment, but I think the really important thing here is things that you might use dictionaries for, like for example, a dictionary is how you'd use a dictionary to store a dictionary of words. Like that's kind of why it's named that. Dictionaries are when you have a like key and a value. So like a thing you want to look up by in a dictionary, the thing you would look it up by, what do you look up a word by in a dictionary? Like the first letter or the word itself, actually. Yeah. So like there's the word and then it's the definition. Has the definition next to it. So a dictionary has a key, which would be the word, and if you want to think of in terms of the analogy, the key is the word and the definition is the value. So when you want to store data that kind of has that sort of pairing with a key and a value, a thing you look it up by, and then the result of it, you use a dictionary. When you want to store, when you don't think about that, when you want to store, like say, all the books on a shelf, and you're only worrying about the ordering of them, you store it in a list. So these are two types of data, lists and dictionaries, and they can encompass most things we have to store in coding can be done with strings, lists, dictionaries, and numbers. They're the building blocks of our code in terms of data. When you're storing things in a list, you can think of a list even as like maybe a stack of cards or something. Like that's a list because it's many items and you care about their order. And we care about the index when we're talking about lists. So that's which number, like the first, the 10th, the third. That's what we care about because we care about the order. And then with dictionaries, we care about keys and values. So we're going to have a quick discussion now with people near you. And if there's nobody at your table, then turn around. And we're going to be talking about which data type to use for different realistic situations. So with those clues I just gave, and there's not necessarily a right answer for these. There could be different interpretations and different reasons to use different data types. Discuss with the people next to you. Should you use a dict or a dictionary or a list for these different situations where you're trying to model a real world situation with your code? Any questions about this discussion? Or about lists or dictionaries? We're going to be giving more concrete examples in a moment, of course. All right, let's get going. So we're going to spend a couple minutes on this and discuss with people next to you what type of data. Let's start closing off discussions in a moment. All right, so let's close out discussion. Let's chat about these types of data quick. For the top one, all the names in the sports team. What ideas do you have? Anyone want to go for that? Yeah.
List.
A list, yeah. I think that's a pretty reasonable way to store them. Did anyone have a reason to use a dictionary out of curiosity?
What type of label?
Yeah, like different positions or something. Yeah, so that'd be another. It depends on how you want to look at the data. There's not one right answer. It's like, do we want to keep them kind of sorted by like which position they're in, their number, like their jersey number or something? Okay, an encyclopedia. What ideas there? What is it? Dictionary? Yeah, dictionary. Yeah, definitely. I think that makes sense. Why would you use a dictionary? Right. The order doesn't matter with an encyclopedia. We care about looking up a particular article, like the article on the Python programming language or whatever. When you go to Wikipedia, you don't want to. It's not that you want to just browse from A to Z, right? You want to actually go right to the topic you want. So yeah, dictionary would make perfect sense. People waiting in line for a table at a restaurant. Who here? You know what we're gonna do? We're gonna do if you went with a list, do this. So it's like the field goal is good. If you went with a dictionary, do this. So not good, I guess. Well, I mean, they're both. We're not trying to make a value judgment on just the dictionary today. It's too late, yeah. So people waiting in line for a table at a restaurant, what do you guys go with? So list or dictionary?
List.
Okay, most people went with list except for not for the country.
How many people are in the party?
Yeah, there we go. There we go, because that actually does make sense, because tables might have different amount available. So if there's a 2-person party available, that might be. You might need to know that. Good. Why did anyone else go with a list? You want to help me out here? Yeah.
Order matters.
Order matters, right? Such as when raising your hand. Yours was a little faster than yours, Marlon. So.
Can you nest them like dictionary?
Yes, you can put them inside of each other. Yeah. So then titles. Health, attack, power, video game characters. So what'd you guys go with? List or dictionary? Mostly dictionaries here. All right, yeah, mostly dictionaries. Anyone want to give a reason why? Raise your hand if you want to go. Why did you go with a dictionary?
Well, because you're.
Yeah, that's
So, like, health would require a definition. Same thing with attack.
right.
So, if you have multiple characters, each one has different attributes.
Right. So if you want to store the different attributes as different keys with different values, a dictionary might be a great way to do it. And again, there could be other reasons, like other ways to do it. It's all about it's all about just knowing or getting used to these different tools. So when you run into a real life problem, you know how to take the concept, you know which concept to use in order to proceed forward. Titles of books that an author wrote. List or dictionary? So you gotta. I got some like lists and like some kung fu lists going on. So yeah, I mean, I think either would work too here. Like, are we caring about like when they're published maybe, or do we just care about the order they were written in? All reasons. Stats of a single athlete. List or dictionary? Both. Got some dictionaries. Yeah, why do you think both?
Because for athletes it matters when they're at peak and when they're not. So
Sure.
order matters.
Right, you may want to have like a list of stats at different levels of of the game or career or whatever. Right. So there's both you might be able to use. It all depends on what particular thing you're doing, really. It's a very open-ended sort of question. Companies' job descriptions. It's also a very open-ended question. So you got a list, dictionary, a little bit of a mix. Cool. What do you think list?
Just like, I don't know, like if you're searching for like a job form or something,
Yeah.
it's usually like in alphabetical order.
Sure, yeah. Maybe that's all you really care about is just the list of descriptions. You don't care about you're not trying to match it up with something else. It's just the job description one after another. So absolutely, those are all reasons you might use it. Also might be a reason to do it, dictionary. Maybe you want to associate like the location of the position open with the title or the salary or whatever. Cool. Okay, so let's take a look at how these look in code. So this is how they look in code. A list has square brackets and then we comma separate everything in them. See this square bracket here, and then we have to close the square bracket there. All of these are inside the list then. So we have Alice, Bob, Carol, and David are four names in a list, and their order matters. So these are in this order, and then the entire list goes inside of a variable. Variables can hold entire lists. That entire list goes inside of the variable. Because remember, we have this open bracket here, so thing on the right, what happens to the thing on the right? Thing on the left. Yeah, so the thing on the right goes in the thing on the left, which means this list goes inside of students in class. Now, students in class is a variable with an entire list in it, not just one bit of data. That variable holds an entire list of data, 4 strings inside of that variable. Over here we have a dictionary, and it's a similar idea. In this case, we're caring about the student's grades. The order is less important. We're trying to associate a student name with a student grade. And dictionaries use curly braces like this. That's what we call these guys, curly braces, kind of like in CSS. And then, again, what happens with this equal sign? The thing on the right goes in the thing on the left, like that. So that means this entire dictionary goes inside of the student's grades variable. And then to store them all, we have the thing there's these little colons here. Dictionaries have colons. Lists do not have colons. Dictionaries have colons. And the colon this is the key and the value. So Alice is 90. Bob has 75. Carol has 75. David has 85. So those are the 2 values associated with each other. And the thing on the left, so I do want to point something out though. We have quotes here. What do quotes typically mean? String. Yeah, and that still means that here too. So we can say that the key is a string. This is what the way we can describe it. The key of this dictionary is a string. The value is an integer. It could be the other way around. We could have an integer as a key and a string as a value, or we could have both strings or both integers. That's all fine. So we could do 10 is like, highest grade. We could do this. That would be the number is the key, the integer is the key, the string is the value. We can also make them both strings or both numbers. It does not, any combination of these is fine with dictionaries. So maybe student letter grades, we do Alice gets an A, Bob gets a C, Carol gets a C, and David gets a B. So in this case, what type of data is this? And what type of data is this? Also a string, yeah. So both the keys and the values are strings in this case. In this case, the key is a string, the value is a number. We can mix up any types we want like that. Maybe we want to do it the opposite order, like, maybe we want to do like, this is probably the least common, but like maybe at some point you want to do it the other way. You want to do like 10 is the okay grade, and then, you want to do the opposite ordering, so you can do that too. Or maybe you just want to do numbers to numbers. That's also fine. Like maybe converting like one system of numbers to another. Maybe you have to do that at some point. But any combination of these are probably the most common. Is just strings are almost always or very often the key. It's very common to have strings as the key, but you could put anything you want there. Any questions about this? So these are how we create them and put them in variables. Lists and dictionaries. Yep.
So you can have keys of mixed data types in the same dictionary?
Yes, absolutely correct. So you can mix it up as much as you want. You could just do, if we wanted, we could just do 103 there. And now, in terms of what this means, the computer will do what I tell it to do. In terms of what it means, I don't know. Like, I just put 100, key 100, value 3, so it's maybe not very useful to put that there. But you can put any mixture of data types on the left or right.
So is it possible to have more than one value for a single key?
No. So the question is it possible to have more than one value for a single key? The answer is no. You only can have one key for one value. You can have more than one, like in this case we have C twice, that's okay, but you can't have Bob twice. I mean, I think it'll actually tolerate it. It won't give an error, it'll just ignore the first one. So you can't have Bob twice like that. Yeah.
But on the right side there, you could have like another.
You could have a list of all the grades that Bob got, but we're not going to go there just yet. But yeah, absolutely, we could nest them. So like maybe we want to store every grade that Bob got. Got a C, then got an A, then got a B. This is how we might do that. So we can actually store. We can do lists. Remember, list is the square brackets up here. So we could mix them up any way we want. But yeah, that's kind of how you'd store multiple values. Any other questions? So let's actually see what this does.
So in terms of memory, so this one takes more space?
I guess so. It's all trivially small. So like all of these are incredibly low memory, so it's not going to be something you need to really worry about too much. You don't really have to micromanage memory that much. They're all going to take a certain amount of space, which will be like, pennies compared to anything else. Like the thing that will take up way more space is just a single Chrome of tab. A single tab in Chrome will take up like orders of magnitude more space than like some of the most complicated Python programs, at least for the stuff we're doing. So, unless you're doing like data processing of like millions of data points or something, like you're doing some sort of data science type thing, none of this will take up much memory at all. So I'm going to go ahead and try this out. So I'm going to do Python 3 containers, and notice when we print them out, we can print out the entire container and it'll actually look like this. So it'll actually format it as the container there. And then I want to point out some interesting things. So if we want to access one element from one of those containers, we use square brackets. So, and this is an important thing, and it's easily confused because, and maybe this was even a bad decision on Python's part because it's using the same thing twice. It's the same character we use when we're creating lists. So you see how we have square brackets when we're creating lists? Completely coincidentally, you also use square brackets when accessing values from a container type, whether it's a dictionary or a list. So if we want to access the student at index 1, we use square bracket 1, square bracket. If we want to access Carol's score, we use square bracket Carol, square bracket. And then that will go inside, then the thing on the right will go in the thing on the left, the thing on the right will go in the thing on the left. That's how we can access those properties. And I want to point out one more thing. How come I say second student equals students in class 1? The reason is because we as humans, we often do first, second, third, fourth. That's how we count typically. Computers, on the other hand, count 0, 1, 2, 3. Which means to access Bob, we actually use 1, because we start counting at 0. Alice is 0. So to access what we might colloquially call the second student, we actually use the number 1 to access Bob. And then that's, again, square brackets to access stuff in a dictionary. It's always square brackets, a dictionary or list. A little confusing because lists also, we create them with square brackets. But don't let those two things get confused in your head in that those are they both happen to be the same character, but they're meaning completely different things. One is accessing, one is creating. Questions? Notice we can also put variables in here instead of quotes. When we put a variable in there, it'll actually look inside of that variable, empty it out, then look for the value. In this case, second student. Which one's second student? It was Bob. Yeah, so we'll actually then get Bob's grade here because we'll look inside the variable second student for the word Bob and then access that and put it inside of second student score. Any questions? If we change this to 0, you'll see it's Alice. Change this. If we change it to something that doesn't exist, like we don't have a Eve student grade, See what I did there? A, B, C, D, E, Eve. Actually, that's unrelated. Change this to Eve. Let's try this again. Uh-oh. Okay, I think I hit a key there by accident. Whoops. So let's, what did I type in wrong? Okay. Okay, so let's try adding in Eve instead there and see what happens. It's gonna say key error Eve because it doesn't exist. So it's gonna error. If I try to access a student that doesn't exist, it's gonna give that error. If I put in 10 there for students in class, that's also gonna generate an error because it's gonna say list index out of range because 10 is too big, it's out of range. The range we have is 0 through 3. Any questions about this before we go on to practice with it? Yeah.
Does indenting inside a dictionary matter? Like,
Nope.
They don't have to be on the same line.
Nope, they can be any level. It's considered neat. Like you could do anything you want there. Python will tolerate it, but it's considered neat to indent it kind of like this, where you just indent once after the curly brace there. Same with dictionaries. Any other questions? Cool. So let's get to quiz today. So we'll be going to the activity after this. We will have a quiz so we're going to have 25 minutes for both the quiz and break. The quiz is going to be on the content we covered last week. So give it your best, answer everything as best you can, and if you finish early, feel free to spend the rest of the time breaking. So again, 25 minutes for the quiz and break. We'll resume class at 8 p.m. exactly. Absolutely. Sheets away. Give you an idea that things need stuff. Yes. I mean, yeah. Let's let it give you any idea what the study is reviewing. Well, there's another way to read it that I'll probably do down below. Oh yeah, you can loop through it in this case. So there's different ways. You can do it without reading directly.
Reads the whole thing alone.
Yes, exactly. Yeah, so there's ways of just getting bits of it, and then you don't lose reading. If that makes sense.
Yeah. You can't read through it.
You can't do a little bit at a time. Anyone else need a quiz? Is there a quiz? Quiz part? haven't yet, maybe turn it in so you still have 10 minutes for a break. It's 10 minutes till class starts again. Step down. Right there. Oh yeah. We're just going to be putting in grading rod out like before, just the lack of a place to enter them for now. Sweet. So grade these four. I think I'll get, let's see, I'll do a little bit more. And the rest over here. Sweet. Very good. Hang tight. What's that?
File the way it shows, like, it brings in each word as its own, or character, or word as its own line. So if you try to like,
Loop through. Oh, when you do dot read like that,
Yeah.
right? Because what happens then is if you try to, we haven't got. We'll get to loops later, but if you try to loop over a string, it loops over every character,
yeah, that's what.
and the dot read converts the file into a string. That's what the dot read does. Converts the file into a string.
Okay.
So if you include the dot read and then use that same code you were just looking at, it'll actually go to every single character in the file.
And put whatever you put around it, yeah.
Right, and if you remove the read, it'll try to loop through every line. Does that make sense?
Yeah.
Cool. So that's that's absolutely true.
That's required for the advanced challenge. So like you do.
Ooh, I don't remember. Yeah.
It's, you asked like to transform every line in the paragraph to wrap in like p-tag.
You don't have to do it with loops. You can do it without it too. But yeah, that's something.
Oh, really?
Yeah. Just by I'd have to double check to actually read that. But yeah, I think you could use a loop for sure. activity 2. So I just want to talk about this activity. Challenge 0 says, remember the first thing we should add to any Python file we're working with? We should add a print statement. So to add a print statement, we can just put in anything we want inside of it. We should just be like, I don't know, activity 2 is ready to go, like that. Whatever you want to say there, and we run that, and we see that message there that confirms that we've edited the right file. And do we make one change at a time and check, or do we make all the changes and check? One change at a time and check. You don't change anything? Just don't check. Don't check. Okay, no, none of those are good ideas. One change at a time and check. Awesome. Stop. Going. Again. Raise your hand for help. Yes. Yeah. Yeah. I would say do it way there. But remember, that's better because it starts there at 1. Yeah, it's okay to be a little more repetitive if it means it's easier to read. Does that make sense?
Yeah, I was just wondering if there was a way to combine the two, not to do all the print statement and still make it to.
There are some ways to do it. Like for example, I'll show you how to do it. But then I'll also say that you should do it that way. You should do it with separate lines. You can add /n. We'll create a new line there. See, that makes 2 lines. However, it's better to. However, doing it like this is just better because it's much more clear when reading, and it's okay to put it in print. Just use a few times. It's just like easier for some to read. So, does that make sense? Where there's written months and read 1,000 times.
I try to do like, so,
You've got them there, yeah.
I try to
What happens? Oh, all at once? Yeah, no, you have to do separate lines.
yeah, I have to do separate
Yeah.
lines.
If you do it all one after another, it's actually going to be basically, so the 0 will be the first element, and then the 1 will try to access the 1 element inside of the first element, so it's reaching further in.
It won't just print the 0 and then 1.
No, it'll actually reach further into every element. But what if you have lists and lists and lists? That's how you access all of
So
those.
if I was nesting,
Yes, exactly. Does that make sense?
it does.
Yep. All right, so I'm going to be going over some solutions now. And I'm going to start with the top one. Favorite animals list, kitty. What are some other good animals in the world? Ostrich. Doggo. What other types of animals are there? Ox? Hawk. Any others? Or is that all? What was that? I'm sorry. Marlin?
Oh,
Okay.
yeah, there is. That is actually a fish.
It's a fish. Is that how you spell it?
Yep.
Nice. All right, Marlin. Sweet. You got some great, great animals here. Yeah. So, using print statements, print each of your favorite animals. So 0, 1, 2, etc. This is how we access them. We could also put them inside a variable if we want. So like fav animal equals this. This would put the 1th one inside a variable. Thing on the right goes in thing on the left. So that's another thing we can do. And so we just keep on going down the list like that. Challenge 3, it's time to write a dictionary. So it should be just like the list, but we want to do the sound of each animal. So, so we can copy these, and so ostrich, I don't know, they squawk, I guess? I really don't know. Squawk. Doggo says hecka a lot. I don't know. Or bark, they bark, don't they? They woof. Woof? Yeah, small woofs or something. I don't know. Hawk, go caw, I guess. And then a marlin, blub. I don't know. I guess that's what a marlin says.
Just scares people.
Yeah. So then challenge 4, we want to do the same thing, but we want to print out each one. So here we how we do a kitty is kitty says this, and we access kitty that way. But then we can do others like ostrich, like that, or and so forth. Marlin, like that. And then we want to probably change the label over here. And again, we can, if we want to put it inside a variable, like we want to say Marlin sounds equals, we can do it like this, and then we could print Marlin sounds if we want, or do whatever we want with it, if we could type correctly. So then that's an example of how we can put the value into a variable, or we could print it out directly. Questions on these so far? So I kind of whizzed through these really quickly. There are solutions. We have some more stuff to cover, which is why I went through this a little bit quickly. Yeah, Alex.
Kind of unrelated. You know how you put the print in separate lines?
Mhm.
In the former example, we use like this in slash thing to
We
separate the
we could, and I think a few people went down that route or tried to go down that route, and then and we could totally do that. We could separate. We could do one print statement with tons of lines. I would say don't do that though. I would say that it's better. So we can actually, if we wanted, we could actually combine like these two lines as an example, like this, like that, if we want. So this is all correct. But I would say this is not very Pythonic because it's less, I think it's less clear than having, then we'd also have to add the /ends here. I think this is harder to read than just having one print statement after another. Personally, I find this like a little more confusing to read than just having one print statement after another, which is, so like this, to me, and I see the repetition, which is easier for my eyes to read. So I think this is a little bit better code. But it is absolutely true that you could do it like this too, where you use that /n to keep them on separate lines. Then you could just do one print statement that does more than one of these lines. Great point.
So wouldn't like the finance and here's the space?
Yeah, I would then do, to add that, I would do this, and then, etc. So this is correct Python code as in it'll work, but I personally think it is less clean and easy to read and maintainable than if we just put them on separate lines like this. Simple is better than clever. That's always,
So is it simple or
this is simpler and less clever in my opinion, because it's just take the thing that works and repeat it, as opposed to trying to be clever with combining different tools to save having, because the only thing we get in the end is we don't have to type print over and over. But that's, I think, worse. I don't think that's a big deal compared to how much more confusing the code could get. Any questions about this? So I'm going to go ahead and just do challenge 5 now. So challenge 5 is we're going to turn this into a combination. So this is pretty tricky. We're going to do a combo of data types. So canines includes dogs and wolves. And look what I did there. I have curly brace here, which is a dictionary. Square brace here, which is a list. So it's a list. It's lists and strings inside of a dictionary. And inside of those lists, we have more strings. So this is how we go about this. And this may seem like a really outrageous thing to do. Like, so many data types is getting so confusing. But you're going to see people do this sort of thing a lot, because once you start wanting to model something more complicated, like in this case a taxonomy of animals, you need to start including these more complicated combinations of data. In this case, it's dictionaries with lists. So we can look up exactly who the canines are, exactly who the felines are, exactly who the rodents are, and store that all in one data type. And then notochord retaining fish, which I don't think includes marlins, sadly. So we cannot use that example here. Sadly. Only hagfish, lamprey, coelacanth, and sturgeon. So important fish fact of the day.
So what about a comma after the wolf?
After where?
The wolf, the string wolf and the comma, and line 89.
Line, I'm sorry,
89.
89, yeah. Oh yeah, there's a comma here. So that's not necessary. We can actually omit that comma if we want. But I think many people like to add that comma so that all the lines look consistent. So the last comma is actually optional, but it's probably, most people like to add it's called a trailing comma, by the way. The final comma there is sometimes called a trailing comma. It's actually optional, but I think to keep everything looking consistent, I think this is a better way to do it, where you have, when there's things inside a dictionary, you don't have to think, or in a list, you don't have to think, is this the last thing or the first thing? It just always has a comma at the end to say, I'm done with this item. So, and notice that in this case, so in dictionaries need commas too. So in this case, we have a dictionary at the end of this square bracket. So like, that's actually, I'm sorry, dictionary, a comma at the end of that square bracket, that's actually the comma that comes from the dictionary. Any questions about that? See how there's like a square bracket, then a comma? That's a comma that's coming from the dictionary. This is the comma that's coming from the, thank you. This is the comma that's coming from the list. Yes?
And that trailing comma doesn't create like an empty space if you're measuring the length, it doesn't.
Nope, doesn't do anything weird. In fact, it's probably preferred to include it. It just is, because then all the lines look the same, right? If I get rid of this, the last line looks different, which like let's say I want to add another item. It's a very common mistake. We want to add marlin incorrectly because they aren't notochord retaining fish. So if we want to add a marlin there, if I didn't check quickly to see if that had a comma or not, I could have just made a mistake there, which is why if you just have a comma at the end of everyone, it's easier to read then.
So that's your second.
What was that?
So like comma and then it's your
Yep. Just a comma at the end of, even at the end of ones that are at the end. So those are, again, trailing commas. So then this is the example solution. Any questions before we go on to the next thing? Another quiz. No, just kidding. What's up?
So when you print the hash,
Yeah.
it's like all pretty much mushed together.
Mm-hmm.
how do you like make a space in between them? I try to slash.
Oh, to print when you print the dictionary? Yep, and yep, hash and other programming languages, right? Ruby or Perl. So the question is, how can we print our dictionaries? Essentially, print them looking nicer, right? And there's a few ways to do that. There is one called Pretty Print, which is built into Python. And you can find an example of it when you just Google it. Whoops, this is the wrong version. Let's do 3.7. And it just has an example, import pretty print, and then you can just pretty print the thing instead, or p-print it, and then it'll format it in a very nice way with spaces and stuff. Another way is Python has something called a JSON formatter, but that's a little bit too advanced. We don't have to go to either of these now, but it does. Both of those are built in, and it can create better lines that way. Another solution actually is actually no. I think those are the main two solutions to answer your question. Pprint is the one that solves exactly what you want. Next week we'll actually learn a bit more how to include. I think we'll even use pprint next week, but it's a pretty print lets you do exactly that. So print out the lines in a more pretty way. Great question. Any other questions? So let's go ahead and get to the next topic then. Branching. All right, so far our code has gone from the top to the bottom, no exceptions, no ifs, buts, or anything else. Top to bottom is what our code has gone. What we want to talk about now is what if we want our code to do different things depending on the situation. What if we want it sometimes to do this thing, sometimes to do a different thing? That's called branching. Branching is where, or also known as control flow, the title of this lecture, is what controls the flow of our program, the flow of execution, the flow of what executes after what. This represents the decision-making capability of coding. The ability of coding to say, if this, then that. The ability of coding to make one decision in one situation and a different decision in a different situation. These are some of the fundamental building blocks of computer programming. If-else is what we're going to be learning now. Branching, when we talk about code, we say it branches into different possibilities based on values in variables. We're going to introduce something now that some of you have already accidentally done and then it yelled at you for, indentation. So indentation, Python syntax is based on indentation. That means spaces count. And if the text is scooted over from the left, so if it's scooted over from the left, that means it's indented. Text that's indented together is called a block of text, also known as, and when we are doing branching, it'll use the blocks to know where to go next. So it'll use the fact that it's indented to know where to go next. And we're going to take a look at that. So kind of an example of what this looks like is imagine where our program is this nice little car that's driving around right in the middle of the road. And it has two options. Does anyone want to take a guess what this actually might be doing? Just based on reading the code up here. So there's code up there. It's doing something. Does anyone want to help me out? Yeah, Alex.
Okay, so it's an if-else statement,
Mhm.
and it's saying that if you guess the number 5,
Yep.
you win, and if you don't guess it, you lose.
Yeah, pretty much. So if the variable guess which is a variable, so guess is a variable, if it is equal to 5, so 5 is stored in the variable guess, notice that's double equals. Double equals is the equals that we know and love. That's equals. Single equals is assignment, double equals is equals. Confusing, but that's how it is. So if the value inside of guess, the variable, is equal to 5, then we go into this branch of code. So it goes into that bit of indented code that says print you win. If the value of guess is not 5, it goes into the other branch of code that says you lose. No matter what, it says game over, because that happens after the branching. Notice how game over is not indented, because it happens after the branching. So the two branches are indented, game over is not. That'll happen no matter what, whether you won or you will lose. It'll still print game over. Questions on this? So this is conditions in Python. Let's try it out. Demo.py. A is 1. Okay, so A equals 1. If A is 1, print A is 1 is what I have here. Let's try A equals 10. What do you think it'll, what do you think it'll do? Nothing, blank, because it won't go into that. Notice else is optional. We could have an else here that says print A is totally not 1. So we run this, now it says A is totally not 1 because it's what branches does is it skips over code. If A is 1, skip down to the else. That's what's happening. That's quite literally what's happening inside your computer too. Is this is way too advanced, way too deep, but it actually your processor knows where to skip to next. Is what it does. When it gets to an if statement, it knows to skip over a certain amount of code if the condition is false. So that's actually what's going on right here. It's if A is equal to 1, it knows to keep on going, and then when it gets to the else, skip over down to after the else. If A is not equal to 1, it knows to skip down to the else and then keep on going from there. So if and else skips over indented code. And we don't have to have equals, we could also have greater than. So what do you think will happen now? Yeah, it'll print the words A is 1, even though A is equal to 10, because I changed the condition here, if A is greater than 1, and 10 is indeed greater than 1. So it says A is 1, very confusingly, but that's what'll happen, because A is 10, 10 is greater than 1, so then it'll say A is 1. To see, so like A is greater. So let's actually think about what it's doing, and this is going to go a little deeper. If this doesn't quite make sense, that's fine. You want the big picture of what if statements do. But I'm going to go a little deeper now. When computers evaluate code, they do it one step at a time, a little bit at a time. So the first thing it does, and we've seen this when we did assignment before, the first thing it does is it looks in the condition. That's all the code that comes after the if and precedes this colon. Notice there's a colon here. This is called the condition of the code. So it looks inside the condition, and then let's start by what's called resolving variables. This is what the computer is actually doing. So what does A resolve to? 10. So A resolves to 10. So the computer replaces now 10 is greater than 1. And now it evaluates this. Is 10 greater than 1? Yes. Which then resolves to the value true. So remember I talked about Boolean values? 10 greater than 1 resolves to be true. And then what happens, once it's done resolving everything to either true or false, conditions resolve everything to be either true or false, it then checks, was it true or was it false? And because that condition eventually resolved to be true, the Boolean value of true, it resolved to be true, then if true will go into this. If it had resolved to be if false, it'll then skip down to the else. And that's what the computer is actually doing, resolving it all down to a single value of true or false. So that's what condition happens to a condition when a computer evaluates it. Questions about this? We can also do strings here. So we can do if A equals, let's say this is like, let's not use A, let's use name equals, Jane. If name equals, Jane, as an example, or Joan, this will not work, because then it'll go to the second thing here. So we can use strings. We can compare strings this way. Another thing we can do with strings is we can check to see if things are inside of each other. So if name equals Jane, if A in name, this will check to see if the letter A is inside of the variable name. Is the letter A inside of name? It is. There's a letter A in there, so that'll work. We can also use this. This is the in operator, the in operator. We can also use the in operator with lists. So if we have fave animals equals dogs, cats, whoops, forgetting the comma, and penguins. Then we could do if penguins in fave animals. That will check to see if penguins is there, then this person has good taste in animal favorites, to be clear. And then otherwise, you should like penguins. So this is another example. So these are all if statements. The only thing I'm changing here is the condition. That's all I'm swapping out. There's many different conditions we can use. This is using the in operator in the condition that lets us check to see if one thing is in another thing. In this case, if penguins is in fave animals. Questions about this? We can do this with dictionaries too. Lists, dictionaries, any of these things.
For dictionaries, could you search up keys and values?
It's only searching keys for dictionaries. Great question. All right. So, if there's no questions, why don't we try doing activity 3, which is on branching. And what's the first thing we always start all activities with?
Print.
Print, yeah.
So what happens if you're indented on the wrong line or not indented?
If you're indented, well, if you use uneven indentation, if it's confusing to it, it'll not run. So if it looks like you have like a weird uneven indentation, it'll say indentation error. Otherwise, it'll try to do what you say. So like if you accidentally indented too much, like you want to do print end of if, and you accidentally put that indented, then it'll assume that's part of the else. Because you can have as much, each of these can be as long as we want them to be. That's something I didn't really show. But I guess just to clarify, we can make as many statements in the blocks as we want, as long as they're all equally indented. So there can be as many statements, all equally indented. And traditionally in Python, you use 4 spaces for indentation, but hopefully your editor, when you hit the tab key, will already indent with 4 spaces. 2 spaces is also okay.
What was this symbol? Was it ampersand?
Yes.
Is that?
It doesn't work for like when it opens up your Chrome. It's this, right?
What was that?
So that
Is it running correctly? Try saving it. Okay, so there's an issue now. So try to fix it. So the first activity is spotting typos. Definitely the funnest of all activities, right? Awesome. Yep, that is, it's a big part of it. I just want to do that. And hopefully it makes it better. Try to spot it up. Spend a lot of time doing this. Yep, better get good at this as much as you can. single equals is assignment, which means the thing on the right goes in the thing on the left.
Right.
It's not equals.
So when you're writing the if else statement,
Always double equals.
got it.
So here's the way to do it. And then what it is the figure assumptions. Single equals is not equals. That's assignment operator, which means the thing on the right goes in the thing on the left. It's putting one thing in another, not equality.
Whereas double equal, you're
Checking, yeah, your value, right? Checking to see if they're the same.
Yeah,
Makes sense?
that makes sense.
Cool. So separate things. Somewhere in there, somewhere in there.
No, it took me a while. I was having brain farts, but I
That's
think
all good.
I
You get
figured it out.
gradually getting there. I think you're supposed to say yes or print yes or no.
I'm getting on myself.
Yep. I'm gonna go ahead and solve challenge 1, so that's the typos one. But then you can keep on working on the others if, so challenge 1 can be solved like this. We can delete, have to start by uncommenting everything. And the first typo is there should be double equals. Single equals does not work. Single equals is assignment. Double equals is comparison. So the first typo is 19, needs a double equals. The second typo is there's no indentation here. Was there a question? No. Okay. Second issue is there's no indentation here. So we need to make sure those are indented. Third typo, is we're missing our colons. The end of if and else, we need a colon.
So those questions were
Well, yes, they were, right. Anyone remember these at all? Ash and Misty, old
Yeah.
enough to drink, and Brock, yep, exactly. It's, those are the same as those. Yeah, that's the thing, Ash and Misty and Brock. I want this to be less than so it's the matches. Yeah, that's all, yeah, that's all.
so for these,
The thing on the right is string, so that they don't have to be, it's a string and quotes. Right. Yes. You can use the solution to get to that.
So I did this for the
Yeah, so you don't want to use ellipse here, just use if and else. Basically. Oh, that's what the, yeah, we don't necessarily have to use it.
Okay.
Because right, no.
I thought it was your.
No, it does say that, right? So else is only with, yeah.
I did it.
Oh, I see. Never mind. I thought you were on that question. Cool, yes. So this is correct. You're fine. I thought you were on challenge 2, which is this. So that would be wrong for challenge 2. Cool. So how Aleph works is it basically go, if this, if Aleph and else, we'll only do one of those.
Yes.
Does that make sense?
Yes.
Yeah, I think it's a little confusing because you have them, 2 of these you have as yes, so you can't distinguish between the 2.
Okay. But it reads correctly.
Okay.
It's semantic E, it's semantic.
Yeah, so yeah, exactly.
That's not a great on the
Right.
area. Yeah. Question. What are you trying to do?
going over some solutions now to challenge 2 and 3. Start with 2. Time for more if statement practice. So for each of these following variables, we want to examine the comment, write code using if and else that conditionally prints yes or no. So is person A equal to Samantha? So we want to do that. We want to write the code for it. We know the answer. Person A is not. It's Johan. But we want to add in the code to check that. So if person A equals Samantha, double equals here because this is assignment, not equality. Double equals is equality. That's checking if they're equal. Print yes. Else print no. Because it says print yes or no if the condition is met. Is person B equal to Samantha? If person B equals Samantha, print yes, else print no. So that's how we check those two. Any questions about this? We're writing if statements that check if a string is equal to another string, because what happens here is it resolves. So this means person B resolves to Samantha, and then it's checking is the string Samantha equal to the string Samantha? Yes, the string Samantha is equal to the string Samantha, so then that becomes true, and it goes into the print yes block. Here, person A resolves to be Johan. Is Johan equal to Samantha? No, the string Johan is not equal to the string Samantha, so that resolves to be false. And that's how the code will run. The key is we have 2 branches, this one, and they're indicated by the indentation. Is x greater than 50? We do if x is greater than 50, print yes, else print no. And then we can check is x equal to 50 the same way. Questions about this? This was challenge 2.
So are those the kind of questions that you can catch on real interviews?
These are a little bit easier than real interview questions typically. So we'll as the challenges get harder and harder throughout this course, they're going to get, by the end, we're going to be doing what's pretty much real interview questions. So, but I mean that's all about learning and getting better, right? Great question. Any other questions? So let's go to challenge 3. I'm just going to go ahead and skip to the solution for challenge 3, so we have time to go on to the next stuff. So here's how we can use and or. So and lets us take 2 conditions and do them both at once, which means if name equals Ash and Pokemon equals Pikachu, it will only print it's Ash with a Pikachu if both conditions are met. That's what and does. It allows us to combine conditions. So now this if statement has 2 conditions because it has and combining the 2 conditions, and both conditions must be met, must be true for it to proceed. Or on the other hand, only one of these conditions has to be true. So if name equals Ash or Pokemon equals Pikachu, then either of those could be true, or both could be true. Both are okay. So either both or either. In other words, at least one condition must be true for the or conjunction to work. So and or are similar but different. And both must be true, or at least one must be true. Questions about this? Elif is one we haven't covered. That's a combination of else and if. So it's when you see elif, think about else and if combined. And the way to think of elif is the reason it's useful is if you have a bunch of conditions you want to check and you only want one of those things to happen. So like if name equals Ash, print hi Ash. Elif name equals Misty, print hi Misty. Elif name equal, so if you have a bunch of conditions you want to check, that's where if, elif, and then finally if none of them are true, you can do an else at the end. And the thing with elif, is it'll only do one of those. You're guaranteed it won't do more than one of those branches. So elif lets you have, in that example of the cars, as many branches from that intersection as you want. So to go back to that analogy, else, elif, so if else, or if elif else, lets you have as many of these as you want, and it'll still only do one of them. Questions about this? That's what elif does. Pass does nothing. Pass does literally nothing. It will nothing happens when it gets to pass. It's only as a placeholder when you want to put stuff there later. Yes, Alex.
So for a pass, it won't like give a print function right after it. It won't print.
No, so pass itself will do nothing. It just skips over pass. Pass does nothing itself. Like the word, whenever Python sees the word pass, it's just like, and just keeps on going. So like, doesn't do anything here. It like, if name equals Ash, it'll do nothing at this point. If we had print after it, it'll still print because the pass itself it's not going to pass the next line. It's just going to ignore that bit of the word pass there.
So what's the point?
Yeah, we can put as many passes as we want. We could do like pass, pass, pass. So, isn't this fun? We can have as many passes as we want. We can make our code even longer and seem like we're doing more work. Okay, there is a purpose to pass. So, other than inflating your code count, line count, the purpose of pass is, the thing is, Python will, if we do this, let's say this is what we want to do. We want nothing to happen if the name is Ash. If we do this, if we do this, Python will actually assume you made a typo or some mistake, and will actually error it. It will say, like, expecting block, expecting indentation. This will not work. This will cause an error. When we do pass is a little bit like, you know how in textbooks sometimes it says this page is intentionally left blank? That's what pass is. This space was intentionally left blank. That's what pass means. So, because otherwise if we try doing this, if we try to leave these blank, Python will actually cause an error because they assume Python assumes that was a mistake. Just like if you opened up your book and like some of the pages are blank, you're like, excuse me, this is a defective copy. There's blank pages in here. But then it says this page was intentionally left blank is letting you know, oh no, this was supposed to be just a blank page. Don't freak out. That was intentional. That's what pass does. Any other questions? But yeah, you can put as many of them as you want. It's fun. Cool. Let's talk about pseudocode now. So our coding projects are getting bigger and bigger now that we're learning more and more code, which is when we have to learn about pseudocode. We already took a look at this last week on Saturday. We had our first glimpse at pseudocode. So let's get more practice with this now. Pseudocode is a way of taking notes in a sort of coding language that we then can use to build our actual code. It's an in-between between human thought and coding, because sometimes you get to a coding challenge and you just don't know where to begin. Pseudocode is the answer. That is where you begin. You start by writing pseudocode, then you can translate that into real coding. Here's an example of pseudocode for rock, paper, scissors. If player A selects rock, paper, or scissors, so it says player A selects rock, paper, or scissors, player B selects rock, paper, or scissors. If they both select the same thing, then report it's a tie. If A selects paper and B selects rock, then say A wins. If B selects paper and A selects rock, then say B wins, and so forth. This is pseudocode for the behavior of rock, paper, and scissors. It may seem very repetitive, but that's actually good because we're trying to write it as cleanly and simply as possible. If someone doesn't know how to play rock, paper, and scissors, they could read this as kind of a what to do, how to play. And well, guess what? The computer doesn't know how to play rock, paper, scissors. We have to tell it how to. And this is the first step, is writing out notes like this. Does anyone see how this could actually be useful for writing the code for rock, paper, scissors? Right? Do you see all those ifs? What might those be? If else, right. Those might just be a bunch of if else statements. So this is a way we can break down our thinking into ifs and else and real code. This is not real code, it's just pseudocode. Yeah, Roman.
So what is the difference between if else or else if and or?
Great question. So if, elif, which is else if combined, and else are those are the main ones that let us control flow. So if and else let us control different paths, or lets us make a combo condition, or lets us combine conditions and make our conditions more complicated, along with and we use them in addition to if. Does that make sense? Great question. That's when we want to combine two conditions into a single condition. Questions before we do a discussion activity? All right, so let's spend a couple minutes now. We're going to spend just maybe 1 minute for each of these. This is going to be quick discussions. People near you, discuss with them. And have one person be the writer, maybe the typist, and just they'll have to type in pseudocode that the other person, as you're discussing, so make sure the person knows who's going to do the typing, or the person who's typing knows they're going to type, let me put it that way. And we're going to discuss pseudocode for each of these problems. We're going to spend about 1 or 2 minutes for each, so we're going to go from one to the next so we can start doing real coding after that. Questions about this? So write down basic notes, basic step-by-step instructions in English with the idea that eventually that could turn into code. Any questions about this? All right, let's get going then. So a couple minutes. I'm going to flip from one to the next. So discussion 1, let's go, and I'll tell you when we're going to switch to discussion 2. Go. Discuss. You guys
Yeah, he's taking off. Yeah, no, it's interview. No, he used to work like in technology. I never did it. He drove me on drugs.
Let's say 7, 10, straight to the doctor.
All right, so we're going to do another 20 or so seconds on this. All right, so we're going to go to the next discussion. Next one, discussion 2. Discussion 2. A bot that automatically answers emails based on rules for customer service.
condition, then they probably check the condition,
How do you know it's a capitalist book?
Call, and then they would like.
so they send them like FAQs where they get to know what they're asking about. Yeah, they have a I'm assuming this is giving them answers, not just like electronic email.
I don't want to know about the people who are switch happy congratulations. Right?
You got it. I
don't know why I'm not already.
database pretty much like take that customer input.
Just a few more minutes for this one, or a few more seconds, sorry, for this one. All right, so let's now go to the next one. A program that automatically grades homework based on certain properties.
It's like a scan. They go like if it's multiple choice, if that's
We spend another few seconds on this.
if that's met, else wrong, it's yes or no.
What's that?
You don't even have to say anything.
There's that one, oh, you have to just look up like shitty robot lady. Yeah, she makes these YouTube videos, she's so funny. Look for her older videos, the newer ones are like more just like podcast Yep. The newer ones are just like product reviews and stuff, and less interesting, but like her older videos are like business. She makes these like ridiculous robots that like special feeding her, or like making food. So like, yeah, it's so like super fun. It's like throwing soup everywhere, like in your face and stuff.
Oh, there we go.
Yeah. Yeah, well, a lot of it's like game GIFs. Yeah, she does. We're all terrible. Those recent videos aren't so good though. They're like more products. Just like,
Oh, for grading.
yeah, right.
She has done collabs with
Yeah, see, there's
Yeah, no, I was saying later.
she has multiple robots. Oh, there we go. She might be a stupid like beat this robot like so much and straight
More generic.
and then creative robot, and then after all, the robot has to like hold the tray.
Oh my god. All right, so let's close off discussion on these. Anyone want to share some of the, or any interesting things that came up during their discussion of these 3 pseudocodes? Any impressions on this? Yeah.
It's kind of hard to go back to N switch.
Nice. Still thinking in code. That's good.
I was caught myself writing print instead of
Yeah.
pen.
Right. No, it's okay in pseudocode to actually slip back into coding here and there
Yeah.
if you already know the code that's supposed to go there.
Right.
But so it's not like it's bad. It just is. Don't let that stop you though. If you just want to say like make it say this or something.
Yeah.
Great point. Any other impressions you got from this or interesting things that came up?
There could be like multiple ways you can do the same.
Oh yeah, there's always many ways to do the same thing for sure. Many solutions to the same problem, and many ways to interpret the problems. These are intentionally left vague, right? But yeah, like as an example, like program that triages patients in the hospital, maybe take blood pressure. If blood pressure is greater than 140, send to room A. I don't know. I don't know. So something like this might be what you're right. And now how you send a patient to room A is completely left blank for now. We don't know what that is. And how we take the blood pressure, that's kind of left out of the picture at the moment. We might taking blood pressure might be another thing we need to pseudocode later to figure out how to do that. So that's kind of how pseudocode works. It's a way to break down bigger ideas. And what we're going to do now is practice that along with more to get practice with using input, which is a brand new thing. Input lets us ask the user, the person using our program, for a question. It lets us ask the person using our program a question on the terminal. And then we're going to use that to write some pseudocode based, or first we're going to do pseudocode, then we're going to start writing more complicated applications using input. We're not going to spend a lot of time on this because we're going to have one more topic to cover at the end of this. So we're going to spend only about like a few minutes on this one. So get started, see if we can get the first challenge 1 and 2 done. Close the terminal, start a new one. That's okay. I don't know what's wrong either. I know that's not very helpful, but that's the best you can do with it. So activity 4, we're not going to spend a lot of time on this, so just get acquainted with the questions, read the questions, I'm going to solve them, and we go right on to the next thing after this. So I'm actually we only have 20 minutes left in class time, and the last activity is a little more important, so I'm just going to go ahead and talk through these challenges quick. So write pseudocode, not real code, for the following application description. An application that accepts a username and password and checks them against known correct values will then tell the user if they're logged in or not. So when writing pseudocode, a really good way to do it in a Python file is to use hash to make a comment, because then you can later write the real code underneath the pseudocode and keep the two contiguous. So when let's check if the user. First. Ask them for username and password. So ask for username and put in username variable. Ask for password and put in password variable. If the password is the correct one, I should say, and the username is the correct one, say that they are logged in. Otherwise, say they are not logged in. So this is kind of how we might do pseudocode for this one. Ask for the username, ask for the password, and then do each of these. Challenge 2 actually has a bit of this code already written. Using input, this is a new thing we haven't used before, input. This will ask someone using our program on the terminal a question. So print the username you entered is username. We can do then the password you entered is password. And let's actually see what happens there when we run this. So username, so I can put in any username I want, like Michael. Password, I can type in my password. So I could type in something else like ASDF 1 exclamation point. Then it says the username you entered is Michael, the password you entered is ASDF JPL 1 exclamation point. So this is how we can ask people questions that are using our program from the CLI, from the command line. You know how Git actually asks you for these things? That's kind of similar code to what Git is using something like this. This is how you can ask you questions on the command line, is by using input. Important thing, if you're using an older version of Python, this is one of the places where it's not compatible anymore. Older Python, it was called raw input, like this. And input did something else, which will cause your program to break in weird ways. So make sure you use Python 3, not Python 2, or just Python by itself. Yeah?
Why do you add the extra space?
Oh, if we don't have the extra space, I think it looks worse, personally. That's purely cosmetic. See, I think that looks worse.
Gotcha.
So can you add another space?
Add another space?
I mean, like for the username on the terminal, can you press space bar then?
We could, yeah. But then the issue is then my username will have a space in it. Then it'll be space Michael, which is actually not what I want. I want just Michael by itself. Does that make sense?
Yep.
But yeah, that is true that we could just hit space there. So then now we want to write pseudocode to do this. This is pretty much walking us through making this program. So we do if they gave the username of Azure Diamond and the password of Hunter2. So if username equals Azure Diamond and password equals Hunter2, print logged on, else print incorrect, go away. So that's how we'd write this in Python, using that and to do both at once, 2 conditions at once. So then we can try this out. So username, Michael, password, ASDF, incorrect, go away. Let's try this again. Azure Diamond, password, Hunter2, logged on. So it's checking those 2 and seeing if they match. Questions about this before we go on to the final bit of tech lecture and activity? Important one. Yeah, sorry, Nick.
So, like, if you're using like an and
Mhm.
conjunction, if you're doing like if you're using numeric values,
Mhm.
if x is greater than 2
Yeah,
and less than 3,
yeah.
do you need to put
X is this.
Again?
Yes, correct. So if you're doing numeric values, it should be like if x is greater than 10 and x is less than 5. That's how you'd have to write it. However, Python has a special shortcut of writing this that isn't in other languages necessarily. So you can actually do if 5x 10. This works fine for Python. If you want to say is in between 5 and 10. But that's just a special shortcut that's in Python. Typically, you have to combine them like this. Well, that actually doesn't make sense. It would be the other way around. But yeah, so this is a way you can write it in Python, correct? Like that. Okay, there's a solution. So we're going to introduce, right at the end, we're going to introduce a new bit of code, a new type of flow control called a while loop. Loops are types of flow control that repeat over and over. A loop repeats. While loop is just like an if statement. We already learned if statements. We already learned if, else, right? We've already learned that. While loops are just like if statements, except they keep on repeating the block of code. if the condition continually is true. So whereas if statements only run once, while loops will keep on running while the condition is true. So in this case, answer equals no. While answer equals no, we can ask, are we there yet? And then we can print, we're there, if it is when it ends. So while loops don't have else, well, they do technically have else, but it does something different than what you might expect. So we're not going to go into what that is, because that's beyond us right now. But while loops don't have else, they just keep on repeating the code and checking to see if the condition is met yet. As an example, we can do answer equals no, while answer, I'm just going to do the same example, equals no, print, are we there yet? And then print, okay, we out of the loop. So we can do Python 3 demo.py. Oh shoot. I just realized I made a boo-boo here. So it's just printing are we there yet, and it never changes answer, which means this is what we call an infinite loop. It'll keep on, and Control C, by the way, if you get an infinite loop, Control C will stop the program. So this is an infinite loop because how can answer change in this loop? It doesn't. It can never change. So the answer will always be no. We'll never be there. This is like, yeah, we're just looping over and over and over and over. This is like every kid's worst nightmare here because the answer is always no. We're never there. So what we need to do is we need to do answer equals input, something like that, just like answer. Now there's a way for answer to change. So we can try this now. Are we there yet? No. 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 There yet? No. Yes. And then, okay, we're out of the loop. So once answer is something other than no, it exits the loop. Because the idea is these two are very similar. If answer equals no and while answer equals no are almost identical, except while answer equals no, we'll keep on doing it until it stops being true. When it gets to the end, it jumps back to the top again. Questions about this? We can do some interesting things with this, like x equals 0. While x is less than 10, print this is x. X equals x plus 1. What do you think this will do? Let's someone want to help walk through this on the projector with me. So line 9 onwards. Anyone want to help me out with this code? Okay, yeah, x is assigned 0, so 0 goes inside of x.
Okay.
What was that?
So while x 0 is less than 10.
Yep, so while 0 is less than 10, is 0 less than 10?
True.
Yeah.
True. So then it goes into the block, then it prints out x, and then what happens on line 12? X is equal to x plus 1. So what is, and then that turns into x, right.
Equals to 0 plus 1.
Yup, x is equal to 0 plus 1, and that turns into 1. X is equal to 1. Is 1 less than 10? Now we jump back up to this and check that again.
Yes.
Is 1 less than 10? Yes. So then we'll print out this is x. X turns into 1. This is x, 1. And then what is 1 plus 1? 2. So this becomes x equals 2. And if we run this, we can see what happens. I'm going to, or 10 to be precise. Yeah. Let's give that a shot. So now we just said this is x0, this is x1, this is x2, this is x3, 4, 5, all the way down to 9, and then it stops because what's 9 plus 1? 10. X becomes 10. Is 10 less than 10? No, 10 is not less than 10. 10 is equal to 10. And then it exits the loop at that point. Questions about this? So this is another example of using while loops. In this case, we're using it to make a number go up by 1 10 times. Yeah.
It doesn't let the program end essentially. It's nothing.
Well, yeah, I mean, we can add more stuff here if we want. Like, yay, out of that loop, exhausted. I don't know if programs get exhausted, but they probably would after doing all those loops. So then that'll happen at the end. And I mean, we can do while loops in while loops, we can do if statements in while loops, we can combine all of these. So like if x equals 3, print got to 3. If x is greater than 8 or 7, let's say, print last few. So then now we run it and it'll go, this is x 0, 1, 2, got to 3 when x is exactly equal to 3. This is x 3, 4, 5, 6, 7, last few, last few, last few for the last 3 of them because while x is greater than 7. Yeah.
Why does it print out got to 3 before it prints out x3?
Great question. Does anyone want to tackle that one? Alex.
Oh,
Because
never
you
mind.
have that line if x equals 3 and you hit it. So
Yeah.
when you hit it, it prints that out.
Exactly, and that happens, x is incremented first, so it goes from 2 to 3, and then it goes to that print statement, it hits that, it prints out x is got to 3, then it goes to the next loop, and it'll say this is x3. So the key is this guy comes before this guy. And that's also why we start at 0, because x starts at 0 and we don't increment it until here. By the way, this is called incrementing. Let me make that clear. When you add 1 to something in programming, that's called incrementing. A shortcut way to write that is this, by the way. That's a shortcut in Python and many other programming languages to increment something by 1. Yeah, question, Alex?
Adding x and plus or plus won't work in Python.
Right, so this will not work. That only works in other programming languages. The closest thing is plus equals 1. That will work in Python. And it's shorthand for this though. It's literally shorthand for this. Python will actually transform it into that before doing it. Any other questions? Cool. Let's spend the last 5 minutes doing this activity, and then we'll quickly, 5 minutes, and I'll spend the last minute going over some solutions to it. And this is getting practice with code and while loops. So challenge 5, while loop practice. I'll be going over it in a few minutes. See if you can get the first one for these 2 challenges. We'll do those. If you have questions, raise your hands, or begin. Don't know what you're looking at. Remember, Control C stops infinite loops. You may get into those in this. So, a lot of typing. That won't do, that's the condition.
Okay.
So that's not actually really what you're thinking it will do. The solution is simpler. Just gonna spend another couple minutes working these challenges. solution is actually simpler than the triangular. But it will not work because the boundary condition, well, equals by itself, but that's not, because that's the sign off.
Yeah.
But think about what you're actually checking. You're checking to see if it's even or odd every loop. Is that really what you want? It will only continue if it's, in this case, odd.
Oh, I see what you mean.
That's not true. You don't want it to only continue if it's odd. You want it to continue even past even or odd. Right? The solution is simpler than that. Okay. Yep, so like imagine, so with the factorial of 10, what would, or you can think of any number by the way, but start at 1, keep on going up to that number, every time you go up by 1, multiply it. Does that make sense?
Yeah.
That'd be kind of the sick approach. Cool. I'm going to be going over some solutions out because we have 2 minutes of class time left. So, first one is, we already did that in class. Second one is, using a while loop, print out every odd number between 10 and 42. And it's very, this is a very tricky one. Or this is a tricky one, but the answer is simpler than some of you approached it with thinking about it too hard, I think. And the answer, there's a simpler solution underneath it. Yeah.
So I said x equals 11,
Yep.
and then I said while x is greater than 10 and less than 42.
We can just do less than 42 because it'll definitely be greater than 10.
X and then x plus increment by 2.
Exactly correct. Yeah. So let's go over why that's the case, why this works. So very good solution there. Every odd number between 10 and 42. Well, what's the first odd number between 10 and 42? 11. So we know we want to start there, and then we just need to stop at 42. And then what is the difference between every odd number? 2. So because if we add 2 to an odd number, what's 1 plus 2 is 3, what's 3 plus 2 is 5, what's 5 plus 2 is 7, we can actually go to every odd number that way. So we can just then, instead of adding 1 every time, we just add 2 every time. This will print out every odd number between 11 and 42. So it's actually just 2 changes from this. We're making a different set of numbers that we're looping through. Challenge 3 is write out pseudocode for a while loop that calculates the factorial of a number. Factorials are is when you multiply a number by all of the integers less than that number. So 5 times 4 times 3 times 2 times 1 is 5 factorial. It's a math term. 5 times 4 times 3 times 2 times 1 is 5 factorial. So, what we want to do now is write a loop that calculates the factorial of a number, and there's a few ways to do it. One thing we definitely we can follow a similar pattern to these though. So let's say let's say number is equal to 5, and what we can do is we can just start counting up to get to 5, right? So while x is less than 5, we actually want to include 5 in this. So we probably want to do while x is less than, so we can do number for 1. So while x is less than number, and we want to include number in this. So there's another way to do that. We can do less than or equals like this. So that's how you type in less than or equal to in Python. I guess we could also do or x equals number. That's another way we could do the same thing. But a shortcut for that is while x is less than or equal to number. And notice that these all start with 1, right? These always start with 1, so we should just have x start at 1. So while x is less than number, we want to increment x, but we want to do another thing. We want to somehow keep an accumulated total of multiplying all these numbers. Some multiplied number, so we do multiplied number equals 1. Then we do multiplied number equals multiplied number times x. So this will actually, every time we loop through this will multiply x by our last total, we could also call this like total, current total or something. Total. I'm gonna make that to make it shorter and easier to write. So if number equals 5, this will go x equals 1, total equals 1. Is 1 less than 5? Yes. So we'll go into the while loop. Total equals total times x. So 1 times 1 is 1, so we put 1 inside of total, because at this point both total and x are 1. Then x equals x plus 1. What is 1 plus 1? 2. Cool. 1 plus 1 is 2. I'm going through this quickly, so you can definitely watch it again if you want a better explanation later. 1 plus 1 is 2, so x is equal to 2. Is 2 less than 5? Yes. So 2 is less than 5. I know with all this coding you begin to doubt the most simplest things. Is 2 less than 5? But it is. We can safely say 2 is less than 5. So then what is, so now total is still 1, x is now 2, so total equals 1 times 2, and we've done this so far now. We've now done those two multiplications. And then x equals x plus 1, so now it's 3. Is 3 less than 5? Yes. Or less than or equal to 5? Yes. So now we do 1 times 2 times 3. We've done 3 multiplications now. So 1 times 2 is 2, 1 times 2 is 3 is 6. Total becomes 6. We make x greater than by 1 again. Now x is 4. So we do 6 times 4, which is 24. And then we do x equals x plus 1 again. Now x is 5. Is 5 less than or equal to 5? Yes, it is equal to 5. So then we do 1 times 2 times 3 times 4 times 5, essentially. So we do the previous total times 5. And then finally, we can do print the factorial of number is total. And this will output the factorial of 5 is 120. So this will actually calculate the factorial that way. Questions about this? So the x equals x plus 1 is just like this. The difference now is instead of just printing the number, we're actually multiplying it and accumulating a bigger and bigger number in order to generate this formula right here. Yeah.
And I assume it would be fine if you drop the x equals 1,
We
the
could.
number is greater than 0, and do an x minus 1 in the loop, right?
True. Yeah, we could count backwards if we want. That would work too. Great question. Any other questions? Yeah, so we could count backwards, forwards. We could also start x at 2 because we don't actually have multiplying something by 1 actually doesn't help at all. So if we wanted to even save one more step, we could start at 2. Any other questions? All right, so
So a lot of these coding are just like trial and error.
yes, coding is a lot of trial and error, is an absolutely correct statement. And playing around and lots of Control C. Remember, Control C kills it when it's running away. Anyone have an infinite loop yet? Got some nods. Awesome, cool. Yeah, so that'll happen. Control C stops the infinite loop. That is it for today. Any final questions? Otherwise, I will see you all on Wednesday. Cool. All right, see you all on Wednesday. And if a few of you have not submitted homework for Thursday yet, please do submit it, even if it's incomplete, still submit it, and make sure, and for next homework, make sure you submit it just on live syllabus. You don't need to use the Q channel at all for the next homework, just as an FYI. Just on live syllabus.
Grab me if you want your quiz back.
Yes, another important thing. Mark has all of your quizzes. You should get them. So, hey, what's up?
I thought I copied yours correct or exactly. But when I run it, I get 6. So I don't know.
Right. So you're printing out the wrong thing at the end.
Oh, okay. Oh, I'm not printing out the total.
Yeah, you're printing out the x, which is always going to be 6 because you got to that. Make sense?